Okay, so I'm hoping that you think this guy is easy. Which one of these has a correlation that is close to 0? Well, this is perfect and it's negative, so this would be -1. And this is almost perfect and it's positive. This would be +1. This is somewhat linear. I would say that this is moderate. And this guy here, I would say, is moderate too, maybe perhaps weak. But because this guy has a curve, remember, even if you put the numbers in, even though that correlation is only to describe linear trends, because if you put the numbers in and you force a calculator, it will get a number close to 0. So the answer is E. Okay, so let's talk about this. And this is mainly about matched pairs. And remember, matched pairs, there has to be a common characteristic. All right, so anything that's before or after, that is definitely a matched pair. So it's not A. Measurements of annual income for each twin. Okay, each twin, that's a common characteristic, okay? Measure of income for both individuals in pair formed by matching 100 people from state A and 100 people from state B based on their level of education. So that means like they'll get people from high school or people with a bachelor's or people with a master's. All right. Now, if they didn't say based on level of education, I would say that C is not a matched pair. But because they said based on level of education, C, that is not matched pairs. Okay. Measurements of annual income for both individuals and pairs by assigning 100 people to pairs at random. Okay, you're just randomly putting people places. There's no characteristic. Okay, so I think D is the answer. Let's look at E here. Measurements of annual income recorded for both spouses. Okay, well, typically you're not going to see a person who is a millionaire and then somebody marrying a person who's a waitress. Okay, typically the people, they have that somewhat similar trend together. So the answer is D. Okay, let's talk here about number 17 because they want us to compare these two box plots. And A talks about more people. All right, I want to again make this clear that the box plots divides the data up into to 25% into quarters. So since they both have 20 people, the quarters would be 5. So there's going to be 5 people here, and 5 people here, and 5 people here, and 5 people here, and 5 people here. Do you see all the quarters have 5? So it has nothing to do with the people with the lowest post rate or the number of people. There are more people. Okay, it's not has to do with that. The people with the lowest pulse rate is a woman. Okay, well, the lowest pulse rate is a man, so that's not B. Okay, and so it says here at least half of the women had higher pulse rates than 3/4. Okay, so here's half of the women had then 3/4. Okay, that looks good. So let's keep that guy. More than half of the men, and I need to erase this because it's just too much. Okay, more than half of the men had a lower, at least half of the females. Okay, I might be wrong about C. My dyslexic's playing right now. Okay, more than half of the men had a lower pulse rate than 3/4 of the women. More than half of the men had a pulse rate, had a lower pulse rate Okay, so here's the upper 50%. And half of them are right here, too. And that is lower than, so it could be D. And if a man and a woman randomly selected from the 40 people, the man would have a lower pulse rate. But how are you going to guarantee that? You can't guarantee that. Okay, so it's between C and D, and I apologize, my dyslexic is playing. So let me just look up the answer, and the answer is C. Okay? Okay, so here we're talking about the mean flight. Okay, so we're talking about means. It's 38. And we go along to read it, and they want to know if it's greater than. Which hypothesis should be tested? Okay. Remember, the hypothesis is about the truth. And in statistics, the truth we use a Greek letter. The letter from our alphabet is the mean of our sample. We don't use that in the hypothesis, so A through C are out. So let's go to Deary, and they want more than, so the answer is E.